Okay, we're going to look at the review for our exam number 4. So the main topics that we're going to be having are how to solve equations algebraically and graphically that are linear, absolute value, quadratic, or radical. And then these are the pages from our handbook. So we're going to start by looking at this first equation. This is an absolute value equation, and so we want to solve it both algebraically and graphically. So let's work with the graphically. So the left side, this is an absolute value equation that has shifted to the right 1 space and down 2. On the right side, this is the x-axis. It's the y equals 0. So there's my x-axis, and my v is going to move again to the right 1 space, down 2. Then it's going to go right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1. Now graph paper is going to be the most accurate, so I'm just trying my best here. But it looks like the answers to the equation, again, that's where my graphs intersect, in this case where the absolute value hits the x-axis, is happening when x equals -1 and when x is equal to 3. So we're going to now solve it algebraically and see if our answers agree or pretty close. So if we're looking at this, we want to isolate the absolute value first. So we're going to add the 2 to both sides. You have the absolute value of x minus 1 is equal to 2. Now we're saying that the absolute value of some number is supposed to be 2. That means that some number could be a 2, or that some number could be -2, because the absolute value of -2 is 2. So that means that x minus 1 is 2, or x minus 1 is -2. So we're going to add 1, that gets me x is equal to 3. Add 1 over here, we get x is equal to -1. These match up with what we saw happening graphically, so these look pretty good. Now one last thing I could do is check that they're right by plugging into the original equation. So again, the original equation is written there. So if we plug in a -1, that's going to be the absolute value of -2 minus 2 equals 0, which this is 2 minus 2, and it does equal 0. To plug in our other value, which would be the 3, okay, we'll cross that off. 3 minus 1 is 2. We're looking at the absolute value of 2 minus 2 equals 0. That's 2 minus 2 equals 0. That checks as well. So the next one we're going to look at is a radical equation. Again, we can look at this graphically. Looking at the left side has the radical function that's been transformed. So the square root function, remember, starts at 0, 0, and then kind of shoots off, but we have it moved to the right 3 and down 1. So right 3 spaces, down 1 space puts us right here. A few more markings. And the structure for this one goes right 1, up 1. We don't go to the left. Again, we only want positive stuff inside of our square root. So it looks like right here, when x is equal to 4, is where we intersect with the x-axis. So that would be our solution. So let's check algebraically. So we have the square root of x minus 3 minus 1 is equal to 0. Let's add 1 to both sides. That's the square root of x minus 3 is equal to 1. Since the radical is isolated, we can now square both sides. So we get x minus 3 is equal to 1. Add 3, we get x is equal to 4, which matches up with what we got graphically. Lastly, we can make extra check on here. If we plug 4 into the original, that's 4 minus 3 minus 1 equals 0, we hope. 4 minus 3 is 1. Square root of 1 minus 1 does equal 0. It checks. Again, solve algebraically and graphically. I like looking at the graph first just to give me an idea of if I have 1 solution, 2 solutions, or what, just to help me out. So looking at this, we have a quadratic equation, and it is a quadratic that's moved to the right 2 spaces and down 1. So right 2 spaces, down 1 puts us here, and it goes right 1, up 1, left 1, up 1. And so we have this quadratic. Looks like our solutions where we cross the x-axis is happening right here at 1 and 3. So when x equals 1 or x equals 3 looks to be our solutions. So let's see algebraically how that looks. So x minus 2 squared minus 1 equals 0. We're going to try and isolate the thing that's squared. That's one way. You can also multiply everything out and then try and factor or use quadratic formula. So we're going to try it this way because I only have one x that I see, so it's really easy just to kind of unwrap it. So this is square root. Now be careful because it says something squared equals 1. That means x minus 2 could be 1 or x minus 2 could be negative 1. Sometimes we write that really quickly as x minus 2 squared equals 1. We square root, so we say x minus 2 equals plus minus 1. So plus 2, this is really x equals 2 plus or minus 1, which is 2 plus 1 to get 3 and 2 minus 1 to get 1, which are the same answers that we see from the graph. Alrighty, looking at number 4, it wants us to solve using lots of different methods. So let's do the factoring method first. So to factor, it has to be set equal to 0, which it is already. And then we want to try and rewrite it as a product. So this is really nice because it's x squared, so we know it's x and x. Now we need numbers that will multiply to 16 and add to 10. Well, that would be 8 and 2. So this tells us that x will equal to negative 8 because x plus 8 equals 0 gets us that. Or x plus 2 could be 0. That gets us x equals negative 2. Those are our two solutions. Now using the other methods, we should get the same thing. So let's look at completing the square. To complete the square, we're going to have to add something to make this a perfect square trinomial. So then we can use the square root property. So I'm going to move the negative 16 over, or the 16 over, so it'll be negative 16, just to kind of keep that over there. So we take half of the 10, which is 5, and then we're going to square that. So we're going to have a 25 minus 25. And so what's nice about that is the beginning 3 terms right here will factor, and they're going to factor to x plus 5 squared. Then we have minus 25 equals negative 16. So to use the square root property, we need to isolate the thing that's squared. So I'm going to move these guys over, and we have x plus 5 squared is equal to positive 9. We're going to use the square root property. Now don't forget, there's 2 things that you can square and make 9. That's both plus and minus 3. So we're going to minus 5. We get x equals negative 5 plus or minus the 3. That's negative 5 plus 3, which will be negative 2. And negative 5 minus 3, which will be negative 8. Which again, we're getting the same 2 solutions that we saw using the first method, which was factoring. Next, we're going to look at graphing. Now, in order to graph this function right here, we really want it to be in that pretty form. So again, by completing the square, we'll be able to see all the shifting. So I'm going to rewrite it even though we already just did complete the square. And I'm going to actually keep the 16 there this time, because really that's what I'm trying to turn into a nice pretty function, a nice quadratic. That's what I'm talking about. We got a 25 and a 25, and so these first 3 will be x minus 5 squared, which actually, no, it should be plus. Let me step back a second. That should be plus. There's no reason why that was going to be minus. So we have x plus 5 squared, and then these 2 guys become minus 9. So this is going to be the function that we graph. Now, using our transformations, this says we're going to move to the left 5, and then this is going to go down 9. So then what that's going to look like, I'm trying to be as accurate as I can, but it's such a big downward. Left 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex. I go up and down, left 1, up 1, right 1, down 1. And so then when I try and sketch this, it's not exactly the best, but because I've already solved the system, or the quadratic, 2 different ways, I know the answer is between negative 2 and negative 8. So on the graph, I can see that that is touching at negative 2, 6, 7, and that looks like negative 8. Not too bad, pretty close. So the graph isn't necessarily the most accurate, but it can help kind of back up what we had said. So I have one other method, and I guess I don't have too much room. I'm going to go up now. The quadratic formula says x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So if I identify from the very beginning, again, it's equal to 0, so I can find my A is the 1, my B is the 10, the C is the 16, then we just have to plug in. So x equals negative b, that'll be negative 10 plus or minus the square root. B squared will be 10 squared, which will be 100, minus 4 times 1 times 16, all over 2 times 1, which is 2. So we get x equals, well, this right here is negative 64. So 100 minus 64 is 36. So I have negative 10 plus or minus the square root of 36 over 2. This is negative 10 plus or minus 6, really. Square root of 36 is 6 over 2. So we're going to have negative 10 plus 6 over 2 and negative 10 minus 6 over 2. That's going to get us negative 4 over 2, which is negative 2, and negative 16 over 2, which is negative 8. Again, same answers. So, reminder, any method that you use here, we should get the same exact answers. Otherwise, you must be doing something wrong. All right, let's scoot on to number 5. This is, again, another quadratic. It doesn't tell me which method to use, so I like to always try factoring first. It's a little bit different here than the last problem with regards to factoring because I have a 5 in the front of my x squared. So if I try and guess and check, I'm putting 5x and x here. The only ways to get 1 would be 1 and 1. But if I try and even play with my signs, there's no way it's going to get me that middle term. If you like doing the x that we've talked about before, that would put a 5 on the top and negative 3 on the bottom. And there's nothing that I can put in here that will multiply to the top and add to the bottom, so I can't even do grouping. So factoring can't work. So then we'll have to use quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So here I have my a is 5, my b is negative 3, and my c is positive 1. So I'm going to get negative negative 3 plus or minus the square root. We're going to take negative 3 and square it, minus 4 times 5 times 1. And this is all over 2 times the 5. So I'm going to have 3 plus or minus the square root. That's going to be 9 minus 20 over 10. Well, 9 minus 20 is negative 11. When I have a square root of a negative number, that means I have to pull an I out. So this will be 3 plus or minus I square root of 11 over 10. That should be my final answer here. Let's see, looking at number 6, again, another quadratic, x squared minus 8x. We could complete the square. It kind of looks like it's set up in that way, and 8's a nice even number, but I'm going to still stick to my factoring. And to factor, I need to make the 3 go to the other side, so it'll be a minus 3, so that way I have it equal to 0. Now, when I think about factoring, there's nothing going to work here because there's nothing that will multiply to 3 and also add to 8, negative 8. So again, I got to use that quadratic formula. Or I could have completed the square. So you could try both ways, and you'll see that we get the same exact solution. So this will be, let's identify A is 1, B is negative 8, and C is negative 3. So we're going to have negative negative 8 plus or minus the square root b squared, so that's negative 8 squared, minus 4 times 1 times negative 3, all over 2 times 1. This is 8 plus or minus. Well, inside our radical, we have a 64, and then this is a minus a negative. That's going to be plus 12, really. So I'm going to have a 76 inside the radical over 2. Now, a very common mistake is to reduce the 8 and the 2. You cannot do that because it's part of a group, but we can try and see if the radical 76 can reduce a little bit. So radical 76, let's see. I know it's 2 and 38, and 38 is 2 and 19, so this pair I can actually take out, and it will be equal to 8 plus or minus 2 square root of 19 has to stay in there, and we'll have 2 on the bottom. Now we can reduce as long as all 3 of these reduce by the same number. So if I divide everything by 2, that's going to be 4 plus or minus the square root of 19 over 1, which would just be 4 plus or minus the square root of 19. Okay, skipping over to number 7. When you first look at this, it looks kind of messy. You might want to try and just simplify first, but I do recognize that there's only w's and no w squared, so this is a linear equation now, but I'm going to distribute this through. It will be negative 3w plus 12 plus 5 equals 10. Taking the negative to each of those, that's negative w minus 1. So you can see that it's a linear equation. Now you need to get all your w's together. So I'm going to add this w over. That's going to be negative 2w. Combining those like terms will be 17. And then 10 and minus 1 are also the same terms on the same side, so it's just 9. Now, I want to move something to the other side. Don't forget, it's always the opposite when you're doing it to the other side. But if you're on one side, you just do it as is, collecting like terms. This will be negative 2w. This actually cancels those guys out. And then 9 minus 17 will be negative 8. Divide by negative 2, we get w equals positive 4. Now to check your answer, remember, you just plug it into the original equation. So I'm going to have negative 3 times plugging in the 4 minus w plus 5. We now hope it's equal to, we're not sure, so I'll put a little question mark, 10 minus, putting the 4 in there in place of the w, plus 1. And so this is going to be, oops, I wrote the wrong thing in here. Erase that. So that's going to be, going back, 4 minus that 4. Okay, so 4 minus 4 is actually 0, so times negative 3 is 0. So plus 5 there, this is just going to be 5. On the other hand here, this is 5, so we have 10 minus 5, which is 5, so it does check. All right, on number 8, we have a linear equation again. It has a little fraction in it though. So remember, if you want a clear fraction, you just multiply by the common denominator. So every term's going to get a 4. So it's like 4 times x over 4 plus 4 times 4 equals 7 times 4. So the reason for that is, again, these will cross each other off. So we just have x plus 16 equals 28 minus 16 from both sides. We get x is equal to 12. Now it does say to check, so let's plug that back into the original. So that's going to be 12 over 4 plus 4 is supposed to equal, we're not sure, but it should equal 7. Well, 12 over 4 is actually 3, plus 4 does equal 7. Yay, we did it. Okay, moving along to number 9. Now this guy, I see a single x, but it has a power 2 on it. So we have a quadratic again, but we only have it in one spot. So we're going to actually use the square root property on this one. We're going to isolate the thing that's squared, which is the x plus 11. I move the 10 over, and so we have it equal to 120. We'll divide by 3 because that's multiplied, so we'll undo it by dividing. We get x plus 11 squared equals 40. Then we're going to take the square root of both things. Remember, this means we're going to have x plus 11 equal 2 because it cancels, but we get both the positive and the negative root. Now this can simplify, this little radical. It's 4 times 10, and that's 2 and 2 and 5 and 2. So I have a pair of 2's. So this is plus or minus 2 square roots of 10. X plus 11 equals that. We'll minus 11 to both sides, so we get x equals negative 11 plus or minus 2 square roots of 10. Now you could have used the quadratic formula if you go back to the very beginning. If you would have simplified and multiplied this guy out, and you would get the same exact answer. All right, let's look at number 10. It's kind of squeezed into this mess. Let's try and erase a little bit of this work, get it out of our way here. All right, so we have a quadratic again, but there's x squareds on this side and an x on that side, so we can't just take a square root to make it go away or to solve for x. But we can put all our x's on one side, so I'm going to minus 12x to move it over, minus 12x. And now we have it equal to 0. We can use quadratic formula, or we could try factoring. Now you notice there's only 2 terms, so if we're going to factor, really we just want to look for GCF and then see what happens. So we're going to pull out 3x as the GCF. We'll be left with x minus 4 equal to 0. That means either 3x equals 0 or x minus 4 equals 0. So we divide by 3, we get x is 0, add 4, or x is equal to 4. Okay, skipping over to number 11, you see just some single x's, so it looks kind of like a linear equation, but it's multiplied times this other, so we have 2 binomials that are multiplied. We should distribute to see what we really have. So we have x squared minus 5x plus 4x minus 20 equals negative 8. So we have x squared minus 1x minus 20 equals negative 8. So you can see it's a quadratic. I want to make it equal to 0, so I'm going to move the 8 over. So I have x squared minus x minus 12 equal to 0. At this point, you can either solve by using the quadratic formula, or you can solve by factoring. So I'm going to try and factor, so I need numbers, let's see, x times x, and then I need numbers that will multiply to negative 12, so that's 4 and 3, and add to a negative, really 1. It's going to be minus 4 plus 3. So x is equal to 4 or negative 3. And you could check both of those. It didn't tell us to, so I'm going to leave that one to you. For number 12, this is an absolute value equation. We want to get the absolute value alone. So 2 is being multiplied. We'll divide both sides by 2. The absolute value of 3 minus 2x is equal to 3. So now that means this blob inside, its absolute value could be equal to a 3, because the absolute value of 3 is 3. Or it could be equal to negative 3, because the absolute value of negative 3 is 3. So again, that blob was that 3 minus 2x. So we need to solve that. We'll move the 3 over, move the 3 over. We get negative 2x equals 0. Divide by negative 2. We get x is 0. On the other side, move 3 over. Negative 2x equals, this time we get negative 6. Divide by negative 2. We get x equals positive 3. Again, you can check that both of those are right by plugging them back in. For number 13, we have another absolute value equation. We're going to minus the 8. Minus the 8, we get negative 6 equals the absolute value of 7x minus 3. So this is asking us absolute value of something is supposed to equal negative 6. Well, wait a minute, absolute value makes things positive, so that can never happen. So there's actually no solution to this equation. There's nothing that will make that true. For number 14, we have a radical equation. And this one's actually kind of nice because our radical is already isolated. So to undo a radical, we're going to square. We got to do it to both sides. So this will be 3x plus 1 equals 11 squared is 121. Minus a 1 over, we get 3x is equal to 120. Divide by 3, and we get x is equal to 40. Again, you can plug that in. And actually we should, because we want to make sure we're checking for those weird solutions, those extraneous ones. So this will be the square root of 3 times 40 plus 1. We hope that we get 11 out of that. Well, this is 120 plus the 1. We're looking at 121. Square root of that is 11, so it does check. So 40 is good. Alrighty, we got 2 more over here. Both of them radical equations. So let's see, this first one. That's minus 3, trying to isolate the radical so we can use the squaring property. Now, right now, I can see that there's a little issue because it says the square root of something is negative 2. If you don't notice those things, you can still go on and say, okay, well, I'm going to square this, and I'm going to square this. We'll get a 4 equals 2x plus 7. But what's going to happen is you're going to end up with something that's not true. 4 minus 7 is negative 3. Equal to 2x, divide by 2, we get x equals negative 3 over 2. So again, right here, I would have seen that there was maybe no solution, but let's check this result. So 1 is supposed to equal 3 plus the square root of 2 times negative 3 halves plus 7. Now, a little reminder, fractions are totally fine to have as answers, so don't be scared by them. I just plug it in to see if it's actually true. So when I multiply 2 times the 3 halves, the 2's will cancel. So I have negative 3 plus 7, that's 4. So I have the square root of 4 sitting there. Now square root of 4 is 2, so this is 2 plus 3. That does not equal 1. It equals 5. Oops. Set that in my head. That's not true. So this won't work. So again, we're going to say no solution. There's nothing that makes sense for that. Last one we have square root of x plus 10 minus 4 equals x. Let's move the 4 over. So we have the square root of x plus 10 is equal to x plus 4. We're going to square both sides, and so we get x plus 10 equals. Now don't forget, to square this means x plus 4 times x plus 4. You're going to get 4 terms here. And x squared plus a 4x plus another 4x plus 16. So combining our like terms, we're going to get x squared plus 8x plus 16. So it's a quadratic now. We want to equal 0, so I'm going to move the x over, move the 10 over. So we're looking at 0 equals x squared plus 7x plus 6. We can use quadratic formula now, or you could try and factor. I want to try and factor, so I'm going to see, okay, this will be x, and I need numbers that will multiply to 6 and add to 7. That will be 1 and 6. So x plus 1 is 0, so x is negative 1, or x plus 6 is 0. That gets me x equals negative 6. Now my equation, these are the solutions right here to my quadratic, but because I started with a radical, which will sometimes have some restrictions, remember the domain and range of that was a little bit different, I'm going to check that my answers are okay. So to check, I'm going to plug negative 1 in first. So square root negative 1 plus 10 minus 4 is supposed to equal negative 1. Well, this part right here is going to be 9, so we have the square root of 9 minus 4. That's 3 minus 4, which does equal negative 1. Awesome, that works. Now we're going to check the negative 6. So we have the square root of negative 6 plus 10 minus 4 is supposed to equal negative 6. Well, negative 6 plus 10 is going to be 4. So we have the square root of 4, which is 2. 2 minus 4 doesn't equal negative 6. So that means that can't work. Our only answer is x equals negative 1.